In this video, I'll be configuring spanning tree protocol and hot standby resolution protocol. Here in this network, what I would like to do is have two different VLANs, VLAN 10 and VLAN 20, and have the different VLAN traffic go up different uplinks to the respective switches. I want a root bridge for VLAN 10 and I want a root bridge for VLAN 20. We'll be using HSRP so that we have a redundant failover if one of these switches were to fail. So here we'll have an access layer, and here we'll have a distribution layer. Most of the protocols will be going on the switches at the distribution layer. So first things first is to configure IP addressing between the distribution layer switches and the routers, and then to configure the VLANs from the distribution layers down to the access layers. So let's go ahead and jump into the terminal. So I have gig 00 going to router 1. Remember to do a no switch port because this is a multi-layer switch, which means we'll also have to enable IP routing 172.16. This is 30.6/30, and nothing is administratively shut down right now. Let's go ahead and interface gig 10, which is the uplink to router 2. With an IP address of 172.16.25.6. Also a /30. Okay. We're going to enable IP routing by just typing IP routing. And let's make sure that we got those interfaces correct, and ping 30.5 as well as ping 25.5, which is router 2. Very good. Multi-layer switch 2. Let's go ahead and enable IP routing now. Interface gig 00 going to router 2. No switch port. IP address 172.16. Link number 4 is 25.10. And I do believe that all the interfaces are not administratively shut down. Just to make sure, do show IP interface brief. So it's up right now. And gig 10 crossing over to router 1. With an IP address of 172.16, I believe that is 30.10. Okay, let's make sure we can ping our routers. Router 2 first is 172.16.25.5. 25.9. And router 1 will be 30.9. Good. Now, all of the other links going to the other switches are going to be trunks. So let's go ahead and interface range. We'll start with the trunk ports going in between the two multi-layer switches, which is gig 30 through 3. That's 3001. Sorry, 30, 31, 32, and 33. And we're going to switch port trunk encapsulation.1q for all of these trunk ports. Switch port mode trunk. Now for these ones specifically, I want to bundle them into a port channel. So I'm going to type channel group, a group number, mode active. This will create a port channel interface of port channel 10 for that channel group. I can exit, interface port channel 10, switch port trunk encapsulation .1q, switch port mode trunk. That port channel 10 is going to be the virtual link between multilayer switch 1 and multilayer switch 2, so that these two switches see all four trunks as being one link, being one bundle. Okay, let's go ahead and configure the other three links going down to the access layer switches. Interface range, I'm using gig 0, 1 through 3, 1 to switch 1, 2 to switch 2, and 3 to switch 3, and switch port trunk encapsulation .1q, switch port mode trunk. Now that all of the interfaces are configured to be trunk ports and that we have a port channel configured on multilayer switch 1, I'm going to go ahead and create VLAN 10 as well as VLAN 20. And I'm also going to create the gateways for VLAN 10 and VLAN 20. Interface VLAN 10. IP address, I'm using 10.10.10. And I have 254 on my diagram as being the gateway for this /24. But what we want to do for HSRP is share that 254 between both switches. So the actual IP address that goes on the SVI is not going to be 254. It'll be one other IP address belonging to that subnet. The other multilayer switch will have the other IP address belonging to the subnet. So we'll use 252 and 253. The higher IP address will determine who is the active router or switch for that standby IP address 254. So if I give multilayer switch 1.253, then multilayer switch 1 will take over as the active router or switch for this subnet, or at least for that standby IP address 10.10.254. Now, the reason why we want a standby IP address is because our PCs need to have a gateway, and only one gateway can be specified. Now, if our gateway was to multilayer switch 1 for VLAN 10, which it should be, if that multilayer switch were to fail, we want it to fail over to multilayer switch 2, which is fine, but now we have to reconfigure all of the gateways on all of our PCs. So instead of having to reconfigure all of the PCs every time we have to fail over, we can just create a standby IP address shared between multiple devices and use that IP address as the gateway. So standby, I can use a group number. I'll use 10 IP and then the IP address 10.10.10.254. So let's do show run and let's go look at our SVI we just created. I have interface VLAN 10, IP address 10.10.10.253, standby 10.10.10.254. Let's no shut. And now we'll also do something similar for interface VLAN 20. Interface VLAN 20, IP address being 20.20.20. Now, instead of using 253 on multilayer switch 1, I'm going to use 252 so that the active router for this one is multilayer switch 2. We want multilayer switch 1 to be the root bridge when we configure spanning tree protocol for VLAN 10, and we want multilayer switch 2 to be the root bridge for VLAN 20. IP address 20.20.20.252/24. Standby group 20 IP, the gateway 254. No shut. Now let's go ahead and do the same to multilayer switch 2. First thing first, I need to interface range gig 3 0 through 3, switch port trunk encapsulation .1q, switch port mode trunk, channel group 10, mode active, creating port channel 10, interface port channel 10, switch port trunk encap, switch port mode trunk, exit. Interface gig range gig 0 1 through 3, switch port trunk encap, switch port mode trunk. The interfaces are all configured to be trunk ports. Let's create VLAN 10, create VLAN 20, interface VLAN 10, IP address. Now we gave 253 to multilayer switch 1. Now we'll give this the IP address of 10.10.10.252/24. Standby 10 IP 10.10.10.254. No shut. Do the same for VLAN 20. IP address 20.20. This time, multilayer switch 2 will have the higher IP address, 253/24. Standby 20 IP 20.20.20.254. No shut. Now what I should see when I do a show standby is two different groups that I've created, a group 10 and a group 20, being for VLAN 10, one being for VLAN 20. And I should see that the state is active. For VLAN 10, multilayer switch 1, I see that the active router is local. And I really want this to update with the other switch. I think maybe they just haven't updated themselves yet, or maybe because this switch was configured first, but multilayer switch 1 should be the standby router for VLAN 20. So let's show standby on multilayer switch 2. Priority 100, priority 100. What I'm going to go ahead and do is write mem on both my switches. Okay. Okay. And I am going to reload them. and hopefully when they come back online, multi-layer switch 1 is the active router for VLAN 10, and multi-layer switch 2 is the active router for VLAN 20. So, meanwhile, let's configure switch 1, switch 2, and switch 3 with their VLANs and trunk ports, and then we'll go back to the multi-layer switches and look at the standby, as well as begin to configure spanning tree protocol. So, do show IP interface brief. I have gig 00 going to the PC. I have gig 01 going to multi-layer switch 1, and gig 02 going to multi-layer switch 2. So let's interface gig 00. Let's switch port mode access, and switch port access VLAN 10. Creating VLAN 10. We'll also create VLAN 20. Let's interface gig 01, switch port trunk encapsulation .1q, switch port mode trunk. That's really all the configurations we're going to need on the access layer switches. We will be going back into these switches and looking at the spanning tree protocol to see what has changed after we've configured it on the multi-layer switches. So let's interface gig 00, switch port mode access, VLAN for the, switch port mode access, switch port access, VLAN. For switch 2, let's go ahead and put PC2 on VLAN 20. Let's remember to create VLAN 10 as well. Interface gig 01, switch port trunk, encap .1q, switch port mode trunk. Do the same for gig 02. And lastly, we'll do the same thing for switch 3, interface gig 00. Access VLAN 10. Let's interface gig 00. Oops, I'm sorry, gig 01. And 02. Okay. Again, that's all the configurations we'll really be needing on our access layer switches. Going back to the multi-layer switches, let's look to see what the standby shows. I hope it shows it correctly. And yes, this time they have been updated correctly. VLAN 10 group 10 state is active. The active router is local. This is multi-layer switch 1 acting as the active router for that IP address 10.10.10.254. The standby router for that IP address is 10.10.10.252. So whenever traffic that's trying to get to 10.10.10.254, it is going to forward to multi-layer switch 1 because it is acting as the active router. For VLAN 20, however, it is in standby. The active router is 20.20.20.253, which is multi-layer switch 2. Standby router is local. Okay, up here the active router was local and the standby router was multi-layer switch 2. I can look at the same thing on multi-layer switch 2. For VLAN 10, state is standby. For VLAN 20, state is active. VLAN 20, active router is local. So 10.20.20.20.254 is going to forward. Anything aimed at that IP address will forward to multi-layer switch 2. Good. That's how we configure HSRP so that we can have redundancy in our network. Let's go ahead and configure spanning tree protocol now so that our two different VLANs take separate uplinks to the respective root bridges. So we'll type on multi-layer switch 1, spanning tree VLAN 10 root primary. This will make multi-layer switch 1 the primary root bridge for VLAN 10. We also want it to be the root bridge for VLAN 20, but the secondary. That's going to complete our failover whenever multi-layer switch 2 doesn't work. So, okay, I should be able to do show run, and I should see spanning tree VLAN 10 priority and spanning tree VLAN 10 priority with the two different numbers. The number for VLAN 10 is lower, meaning that it has a higher priority than VLAN 20. When we do this on multi-layer switch 2, we can expect these two numbers to be swapped, because VLAN 20 will have the higher priority and VLAN 10 will have the lower priority for multi-layer switch 2. Okay, so let's go to multi-layer switch 2. Spanning tree VLAN 10 root secondary. And for 20, we want it to be the primary root bridge. Okay. That's really all that's needed to configure spanning tree protocol so that you can have different uplinks for different VLANs and to create different root bridges. Okay, I'm going to go ahead and write mem really quick. I'm going to turn one of these switches off now. Multi-layer switch 2, I'm going to turn off, and we want to see how this affects our network when it comes to sending VLAN traffic for VLAN 20. Now that the root bridge for VLAN 20 is down, what happens to that VLAN 20 traffic? Well, let's go to multi-layer switch 1 and let's show spanning tree. Notice for VLAN 10, this bridge is still the root. And now notice for VLAN 20, saying that this bridge is now also the root for VLAN 20. So now multi-layer switch 1 is acting as the root bridge for both VLAN 10 and VLAN 20. On switch 1, show spanning tree. Gig 01 going to multi-layer switch 1 is the root role, and in the forwarding state for VLAN 10, that's normal. For VLAN 20, now gig 01 is in the root role and also in the forwarding state for VLAN 20. So now both VLAN 10 and 20 traffic are being forwarded to multi-layer switch 1. Let's go to PC3 really quick, which is connected to switch 1, and let's give it an IP address. I believe it's just IP 10 and 10.10, and we're going to use the 254 for the gateway. Okay, now PC3 should be able to ping 10.10.10.254. That's its gateway. Okay, PC3 belongs to VLAN 10, pinging multi-layer switch 1 for 10.10.254. I'm going to turn multi-layer switch 2 back on. Once it's booted up, I'm going to turn multi-layer switch 1 off, and then I'm going to try to ping my gateway from PC3 again. And I want to see if PC3 can still ping 10.10.10.254, even though multi-layer switch 1 is turned off. If it can ping 10.10.10.254, then we know that we have configured hot standby resolution protocol effectively, as well as spanning tree protocol, because now the root bridge has switched over to multi-layer switch 2. So multi-layer switch 1, I'm going to go ahead and stop it now. Let's try to ping my gateway. And notice you can ping the gateway still. This is belonging to VLAN 10, pinging VLAN 10's gateway 10.10.254, but this time on a different device, multi-layer switch 2. Let's go ahead and turn the switch back on. So virtually, VLAN 10 traffic is taking the 3 uplinks to multi-layer switch 1, and VLAN 20 traffic is taking the 3 uplinks to multi-layer switch 2. So for multi-layer switch 1, I want to create a default route 0.0.0 quad zeros, and my first choice is to send traffic to router 1. So I want VLAN 10 traffic to be able to go to router 1 in order to get to the internet. The same thing for VLAN 20. I want VLAN 20 traffic to get to router 2 to get to the internet. So I'm going to set a default route on multi-layer switch 1 aimed at router 1, 172.16.30.5. Now in the case router 1 were to go down, I don't want multi-layer switch 1 to not be able to reach the internet, so I need another backup route going to router 2. This will be 172.16.25.5, and since the destinations are the same, or the destination networks are the same, we need to have a priority. I'm going to put priority 2 on the second route so that the default route to router 1 takes priority over the default route going to router 2. So if I do show IP route, I should see a gateway of last resort going to router 1, 172.16.30.5. Good. In the case router 1 were to turn down, this gateway of last resort would change to 25.5. On multi-layer switch 2, IP route quad zeros. My default route of choice is to go to 172.16.25.9, that's router 2, and I'm going to have a backup route to 30.9 with a priority of 2. Do show IP route, I should see a gateway of last resort going to 172.16.25.9, and in the case router 2 were to fail, this would change to 172.16.30.9. And of course, if we want full reachability, router 1 needs to know about the networks for VLAN 10 and VLAN 20. I can set up static routes, 1 to the 10 network, 10.10.10.0/24. My first choice is to go to multi-layer switch 1, 172.16.30.6. Of course, in the case where multi-layer switch 1 were to fail, I need a backup route to multi-layer switch 2, since multi-layer switch 2 is going to act as the secondary root bridge. So that is 30.10. And of course, that's a backup route, so it needs a higher. Router 1 also needs static routes to the 20 network, so IP route 20.20.20.0, 255.0, and its first choice is to go to multi-layer switch 2, so I'm going to do 172.16.30.10, and a backup route to the 20 network going to router multi-layer switch 1. And of course, we need a priority because we have 2 routes to the same network. Now let's do show IP route. And I see one static route to the 20 network via 172.16.30.10 being multi-layer switch 2. And I see one static route to the 10 network via 172.16.30.6. If one multi-layer switch were to fail, these routes would change based off of who the next hop is because of our static routes that we just configured. Last thing to do is create a default route to the internet. This is router 1, so 30.1 is to the internet, just like that. Now for router 2, IP route to the 10 network, first choice to the 10 network is multi-layer switch 1. This is link number 3. So that is 25.5. Oops, .6 I mean. And of course, the backup going to multi-layer switch 2 being 25.10, the higher priority. I mean, cost, administrative distance. Higher administrative distance, not a higher priority. This route will take the higher priority because this has a higher administrative distance. Okay. 20.20.20.0 now. And we want it to go to multi-layer switch 2 first. And we want the backup to be 25.6. So we raise the administrative distance for the backup route. And of course, router 2 needs its own default route to the internet also. 25.1. Let's open up PC3. Let's ping my gateway again. Make sure that we're still good there. Now let's try to ping 172.16.30.5. What I did was configure a priority for VLAN 10 for the standby IP address on interface VLAN 10. What happened was when we rebooted our multi-layer switches, multi-layer switch 1 went into standby for both VLAN 10 and 20. So I went into interface VLAN 10 and I configured standby 10 priority 20, and I gave it 50. So I gave VLAN 10 a priority of 50. Then I put the command preempt. What preempt does is it allows the device to overthrow any other device with a lower priority. So I also went into multi-layer switch 2 and gave its priority for VLAN 10 20. And so because multi-layer switch 1 has priority 50, it can overthrow multi-layer switch 2 because it has a lower priority. So again, when I rebooted my switches, my state was in standby for VLAN 10 and 20 on multi-layer switch 1 when the state needs to be active for VLAN 10. So now I was having trouble pinging the 10 network from router 1. So now router 1 can ping that 10.10.10.254 and should be able to ping 10.10.10.1, yes, which is PC3. So just to recap, we configured spanning tree protocol on multi-layer switch 1 and multi-layer switch 2 so that our different VLANs take separate uplinks to the respective root bridges. We configured hot standby resolution protocol so that there is a shared IP address between the two switches so that our PCs can have a gateway in case one switch were to go down. We configured default routes and static routes on our core layer, as well as backup routes for redundancy in the case where a device were to go down. And then we also set a priority on our on our standby IP addresses so that our switches can know which device is acting as the active router for those VLANs gateways. So that's it. That's how you configure spanning tree protocol and hot standby resolution protocol.